Greetings, welcome to our presentation, Topographic Maps. Our presentation is targeted to the senior and FPT phase, especially the senior phase. The topic is applying map skills and techniques, more on the contour lines, scales, topographic features, and so on. First, let us look at the contour lines. What are contour lines? Contour lines are lines on a 2D map that connect points of equal heights. They show the heights, the shape, land surfaces. They help us visualize mountains, valleys, slopes, flat surfaces on a topographic map. So contour lines, they can help us identify any landform on a map based on how they are placed, whether they can be widely spaced, they can be closely spaced, uneven, or irregular. So, closely spaced contour lines means we have a steep slopes or the land rises or falls sharply. Widely spaced contour lines means we have a gentle slope. Even spaced, the feature has a uniform shape. And irregular spacing contour lines, it means an uneven slope, or we have mixed, steep, and gentle areas. Contour intervals. What are contour intervals? It's the vertical difference in elevation between two consecutive contour lines. Mostly, we have a contour interval. The small contour interval that is mostly used on the map is 5 meters. It is used for flat areas to show details. We also have the mostly used contour interval, which is 100 meters. It is used for mountain areas to avoid clutter. If contour lines are showing a mountain, so a mountain usually is high, they will definitely use a contour interval of 100 meters.
Greetings, I'll be doing map scale and proportions. Map scale is the relationship between distances on a map and the corresponding distances in the real world. It tells you how much the real world has been reduced to fit on the map. So there are 3 different types of scales. We have a verbal scale, a graphic scale, and a representative fraction. Starting with the verbal scale. So a verbal scale expresses the relationship in words, such as 1 inch is equal to 1 mile, or 1 centimeter represents 1 kilometer. This is the easiest scale to understand, but it can be problematic if the map is enlarged or reduced. And then we take a look at the graphic scale, also called a bar scale or linear scale. So in most times, you will find the bar scale like on the bottom of the map. So the graphic scale uses a line marked with distances. It looks like a ruler drawn on the map, typically showing units like miles or kilometers. The advantage of a graphic scale is that it remains accurate even if the map is photocopied or resized, since it changes proportionally with the map. And then we take a look at the representative fraction. So this type of scale expresses the scale as a ratio, such as 1 is to 24,000 or 1 is to 50,000. This means that 1 unit on the map equals that many units in reality. For example, 1 is to 50,000 means 1 centimeter on the map represents 50,000 centimeters or 500 meters on the ground. The representative fraction is universal and works with any measurement system. Then we take a look at proportions and measurements. Large scale versus small scale. This is a counterintuitive which is more like a scale that is, it's actually something that is unexpected. A large scale map like 1:10,000 actually shows a smaller area with more detail, while a small scale map like 1:1,000,000 shows a larger area with less detail. Think of it in terms of the fraction. 1/10,000 is mathematically larger than 1/1,000,000. Calculating real distances. To find actual ground distance, multiply the map distance by the scale denominators. For instance, if 2 points are 5 centimeters apart on 1:50,000 map, the real distance is 5 times 50,000 is equal to 250,000 centimeters, or it can be 2.5 kilometers. Map accuracy. Larger scale maps are more detailed and accurate for navigation, while smaller scale maps are better for understanding regional geography or planning long distance travel. The scale you need depends on your purpose.
The focus for now is on the topographic features. The topographic features are the landforms that are found on a map, the natural landforms. These landforms that we're going to be talking about, the first one is the hill. The hills are the elevated landforms that are lower than the mountains, often showed by closed concentric of the contour lines on the map. These sometimes they show a round or oval patterns. You can make a reference to the map. On the map we have a hill on D5. On the D5, how do you see that is a hill? The contour lines are increasing towards the center, and the lowest height we find there is 139 and the highest height is 185. So we can see that there's an elevation there. And then we also have the gentle hills. The gentle hills are the widely spaced contours of which you can make a reference to A11. A11 is not really a hill that is too much of a hill, but it resembles a hill because the contour lines are widely spaced, but you can also see that there's an elevation in the soil. The hills normally they rise from 100 to 60 to 600 meters above the surrounding terrain. And then we go to the second one, the valleys. Our map that we have chosen doesn't have much of the valleys, but we can explain for someone who doesn't really get the example of it. The valleys are the low-lying areas between hills or mountains. In order for yourself to find a valley, you will see that there is a mountain on the other side with close concentration of the isobars of the contour lines, and also there's a mountain on the other side with close concentration of the contour lines, and all of the contour intervals or the height is increasing towards the center. But if there is a space in between, that is a valley. Most of the valleys form a U shape that is pointing upstream, and sometimes most of them they show a V shape that points upstream. They indicate the steep sides often carved by the rivers. We go to the third one, the plateau. The plateau is a flat or gently rolling elevated landform. We can make an example about this, the Cape Town. In Cape Town, we have the Table Mountain. The Table Mountain is one of the famous topographic landform we can make an example of. It has a flat top or gently sloping top, but on the side you can find that it's very steep. So to make an example of this one, you would see the shape of Cape Town mountain, the Table Mountain, and then it shows that on the top is gentle, but on the side is steep. On maps, they display a widely spaced contours across that flat top surface, but on the sides, closer contours at the edges representing escarpments. These plateaus maintain relatively consistent elevation over large areas, and they rise distinctly above the surrounding lowlands. We go to the last one, of which are the mountains. The mountains, we can find them on the map. We have them on A4, we have them on B2, we have a piece of it on C2. These mountains, these are the landforms that rise up prominently above surroundings, typically over 600 meters, shown by numerous, closely packed contour lines converging towards the peaks. The contour patterns reveal features like the ridges, the spurs, and the saddles. Closely spaced lines, they indicate a steep slope, and the summit is marked by the highest closed contour on the spot elevation. So if we look at the map, we can also find that besides having mountains, we also have depressions. The depression is also found on G6. How do we find that it was a depression? We can find it's a depression because the contour lines, they are decreasing towards the center. As you can see from an example, the highest contour line we can find is 153, and the lowest to the center is 20.
So in today's lecture now we're going to look at the water bodies, and in the water bodies there are rivers, lakes, oceans and dams. But we are going to look only at two features, which is rivers and lakes. So now we're going to start on rivers. The rivers are the near water features flowing from high to low elevations, depicted as single blue lines, narrow streams or double lines. Wider rivers are shown by the direction of flow that follows the V-shapes pointing upstream. The rivers appear in valley bottoms and may show meanders, caves, tributaries joining the streams and confluence junctions of the points. So now as we're going to look at the rivers, I'm going to just point reference regarding to the map. So we're going to look at A3. At A3 we see only one tributary that joins the mainstream from a high-lying area to a low-lying area. As we see those tributaries, there's only one single tributary that will join the mainstream. As we see, the contour lines are more closely together, which shows us it is the high-lying area where the river starts. And then we're going to move on. We can look at the meanders. There's also a meander at H5. There's a meandering river. We can see the curve there. We can also see the slopes. There is an curved slope and a slip of slope. As we move on now, we take a look at confluence. As you can see, a confluence, it is a single tributary that joins the main river. This is a point where we see the confluence. And then we move on to the lakes. As we move on to the lakes, lakes are standing water bodies that are shown as blue colored areas with flat surfaces. A single contour line surrounds the perimeter, indicating uniform surface. Size varies from small ponds to large lakes. Shorelines details show inlets, bays, and peninsulas. Some maps indicate the bathymetric contours. And then we move on to make a great reference. We go to the D9. As we see there in D9, we see a lake that is shown there near the recreational area and the school. We can see a lake there, and it is a small pond lake. Then we move on, and then the lakes are usually shown in the topographic map. They are more visible on the topographic map.
Let us now move on to coordinates. Coordinates can be defined as numerical values that pinpoint an exact location on Earth's surface. They are divided into two different types. We have lines of latitude and lines of longitude. The lines of latitude can be defined as lines that run horizontally from east to west. They are parallel to the equator, which is why they are also called parallels. All the lines are parallel to each other and they never meet. They range from 0 degrees at the equator to 90 degrees at the poles. Now, longitude are lines that are also known as meridians because they measure how far east or west a location is from the prime meridian. The prime meridian runs through the Greenwich. Lines run vertically from north to south, and they range from 0 degrees to 180 degrees east or west. A Greenwich meridian is a line that runs from north to south, and the equator is a line that runs from east to west. Note that every location has a unique pair of coordinates. The format is always latitude first and longitude last. The coordinates are written in degrees, minutes, and seconds. 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds.
Now let's move on to grid references. Grid references are a system for pinpointing a location on a map using numbers grid overlay. It's particularly common on topographic maps. A grid system consists of vertical lines which are called eastings. We have horizontal lines which are called northings. We have labels which are letters or numbers. We have grid squares which form where lines intersect. We have types of grid systems. Firstly, we have Universal Transverse Marcator, EUTM, the Global Military Grid. It divides the world into 60 zones, each 6 degrees of longitude wide. It uses meters as units. Secondly, we have National Grid System, which is a country-specific framework. It uses metric measurements, usually kilometers. It's designed for local mapping accuracy. Each country may have its own system. So maybe you're asking yourself why we are using grid systems. Well, we are using grid systems because it specifies location finding without needing latitude or longitude. It works well with paper maps when technology isn't available. Often uses meters, making distance calculations straightforward.
Class, you are touching on map application and skills. Map application and skills is whereby you use map to determine the best route from one place to another. So we'll focus now on applications for navigation and route planning. It's whereby we apply road trips and traveling planning, hiking and outdoor expeditions, emergency services whereby you need an ambulance, police, fire services, or logistics and delivery services. I'll also touch on skills involved within map application and skills. So when we gain a skill of reading map keys, symbols, and skills, measuring distance using scale bars, identifying landmarks, roads, rivers, and settlements, planning shortest distances, safest routes. So when you need a shortest route, or you want to navigate a shortest route, you need what? A map to find such routes. So in real world example, for instance, a real world example is whereby you look at Google Maps, GPS devices, and traditional paper maps. Or mostly traditional paper maps we find them on gas stations. We move along on analyzing map data, focusing on elevation and slope. So through elevation is whereby we are shown using elevation is shown using contour lines, spot height, and trade beacon. It also helps in understanding terrain heights and landforms. So focusing on slope is whereby a gradient of the land is steep or gentle. So to test whether the gently or steepness is derived from spacing of what contour lines. So when the gradient is steep, when the gradient of a land is steep, it's whereby you look at what a close spaced contours, or gently for a gentle slope is whereby contours are widely spaced. We'll move along to maps in real world. So just a brief definition is whereby a detailed map showing a natural and man-made features. So in terms of applications, we apply topographic maps in urban planning and land use management, tourism and outdoor recreation, whereby you look at hiking and camping. For military operations, we also use topographic maps. Also in environmental management, the topographic map is what is used. There are key features to interpret Lapa. We have physical features like river, mountain, and forest. Human features, it includes roads, buildings, and power lines. Those are man-made features. Physical features are what are natural features. We have what map orientation, use what compass direction. Also, there are benefits, which includes what providing accurate large-scale representation of area that also help in linking that links physical geography with human activity.